Good day, everyone. So today we shall be looking at questions and answers on speed, velocity, and acceleration. All right. So without much ado, let's dive into this section. Okay, let's see question one. Question says, a student walks a distance of 3 kilometers in 20 minutes. Okay, calculate his average speed. Now, when solving problems in this subject, it's good that we write out our parameters. All right. So here we are given distance of the distance the student covered to be 3 kilometers. But then we have to convert this distance to its SI unit, which is meters. So 3 kilometers in meters is 3,000 meters because we multiply 3 kilometers by 1,000 to convert it to meters. That will give us 3,000 meters. In 20 minutes, we are given time also to be 20 minutes. And then we have to convert time to its SI unit, which is seconds. Okay? So converting 20 minutes to seconds will be 20 multiplied by 60, and that will give us 1,200 seconds. And then we have to find the average speed. By formula, what is the average speed? Average speed is distance over time. And here we've gotten our distance to be 3,000 meters and our time to be 1,200 seconds. Dividing them, we have our average speed to be 2.5 meter per second, because the unit of average speed or speed generally is meter per second. All right, so that's very straightforward. Let's take another question. It says a driver traveling at the speed of 115 kilometers per hour received a text message on his mobile phone. Of course, as a good driver, you're not allowed to be pressing your phone. However, you cannot stop message from entering your phone. How far is he in kilometer? 20 seconds later from when he received the text. Okay, so we have to find the distance he covered 20 seconds later after I received the text. Now, our usual manner, we write out our parameters. Okay, a driver traveling at a speed of 115 kilometers. That the speed of the driver is 115 kilometers per hour. Okay, so speed by SI unit is in meter per second, but it can be another unit as well, kilometer per hour, kilometer per minute, and so on. In this case, we are giving it to be 115 kilometers per hour. And then we have to find the distance, because the question says, how far is he? So we're looking for the distance that the driver covered in 20 seconds after he received the text message. Now the time is 20 seconds. Now in this case, the time is already in its SI unit, as a second. But then, remember the question says, how far is it in kilometers? Meaning that our distance should be in kilometers. So for us to make our distance be in kilometers, firstly, the speed will remain 115 kilometers per hour, because we are having our distance to be in kilometers. So we don't have to convert speed to meter per second. So we leave it in kilometers per hour. And then our time, which is in seconds, needs to be converted to hour, because the speed has its time to be in hour. So 20 seconds in hour will be 20 divided by 3,600. And everything here is now in hour. So our 20 seconds in hour is now 20 over 3,600 hour. The reason being that we want to get our distance to be in kilometer, and we really love the hour to cancel the hour here. That is why we have to convert this. Now, coming to the formula, distance by formula is speed multiplied by time. So when you multiply speed by time, in the question we already have speed, which is 115, multiply our time will be converted to hour, which is 20 over 3,600, and that is it here. So multiplying all of these is going to give us 0.639 kilometers. It's in kilometer now because we never tamper with the kilometer. Okay, and the hour has cancelled out. So the distance covered is 0.639 kilometers. Okay, so let's see another example. It says a train moves with a speed of 54 kilometers per hour for 1/4 minute. Find the distance traveled by the train. Again, let's find our parameters. Speed is given in the question to be 54 kilometers per hour. But then we need to convert it to what? To its SI unit, which is meter per second. So 54 kilometers per hour in meter per second is 15 meter per second. And how do we achieve that? We multiply 54 by 1000 and divide the result by 3600. This will give us 15 meter per second. The time is 1/4 minute, and 1/4 minute is 1/4 minute. 1/4 is 1/4. Now we need to convert time to its SI unit, which is seconds. So converting it to SI unit to be multiplying 1/4 by 60, because 60 seconds make a minute. So 1/4 times 60, and that will give us 15 seconds. So 1/4 minute in seconds is 15 seconds. And then distance by formula is speed multiplied by time. So we have our speed to be 15 meters per second by conversion to 15 multiply. Our time is 15 seconds. 15. So 15 multiplied by 15 will give us 225 minutes. Okay, let's go on to see another question. Here, it says two cars moving in opposite directions on the same straight road with velocity 80 km per hour and 60 km per hour respectively pass each other at a point. Determine the velocity of the first car relative to the second. This question is based on relative velocity. All right. Now remember that the two cars are moving in opposite direction. So whenever two cars or two objects are moving in opposite direction, to find the relative velocity, all you need to do is to add up. Oh, there's an error here. It ought to be a plus sign. So when they move in opposite direction, you add up to get the relative velocity. Okay. All right. So to get a relative velocity, you add up. So velocity of the first car is 60 km per hour. Velocity of the second car is 80 km per hour. And we have to find relative velocity because they are moving in opposite direction. To find the relative velocity, that will be V equals to velocity of the first car plus velocity of the second car, and that's 80 plus 60. That is 140 kilometers per hour. All right, so that's it. Okay, so whenever two objects are moving in opposite direction, the relative velocity is always added up. Is obtained by the addition of the velocity of the first one and the velocity of the second one. Okay, but whenever they are moving in the same direction, to get the relative velocity, you just need to subtract. You subtract the velocity of the smaller one. You subtract the smaller velocity from the bigger velocity, and that will give us the relative velocity when they are in the same direction. Okay, let's take one more question and we'll wrap it up for today. All right. So, question 5 says a cyclist increases speed from 5 meters per second to 15 meters per second in 4 seconds. Okay, calculate the acceleration and explain its physical meaning in terms of the motion. Okay, now from what we have here, we are giving the initial velocity, which is 5. We use u to represent initial velocity. So we have our initial velocity u to be 5 meters per second, and the final velocity, which is 15, we use v to represent that. V equals 15 meters per second. We are given the time it took the car to increase from 5 to 15. 4 seconds. So time there is 4 seconds. And we have to calculate the acceleration, which is the A. By formula, acceleration equals v minus u over t. That means final velocity minus initial velocity over time. So here that will be 15 minus 5 over 4, and that is 10 over 4, and that is 2.5 meters per second squared. So the meaning of this is that the car actually accelerates from 5 to 15 meters per second, because whenever we talk about acceleration, it simply means change in velocity. So the velocity of the car or the speed of the car change from 5 to 15 in 4 seconds. So when that occurs, we say acceleration has occurred. The car has accelerated. All right, so that's it. Okay, so this is where we shall be drawing the curtain today. Thank you for listening. Till I come your way again. Bye for now.